something that's slightly new. Lesson 2.7, consecutive integers. First of all, just the meaning of this. Consecutive means in a row. The Giants have not won consecutive World Series, right, in a row. So far it's only even years, although maybe we'll beat the Dodgers again tonight, get closer. So consecutive means in a row. So for example, if I said consecutive even integers. Consecutive even integers. 2, then what? Well, actually, let me go above that. Let me just say consecutive integers. 1, 2, 3, and so on, right? Just whole numbers. Integers means whole numbers. So consecutive integers, we're just going in a row. Now, here I started with 1. You may not always start with 1. I'll show you what I mean in a minute. If I said consecutive even integers, and I start with 2, what would come next after that, Carissa? 4, and then 6, 8. Who do we appreciate?
My mom.
Oh, thank you. Or like we used to do when I was in school, we'd say 3, 6, 9, 12. Who do we like besides ourselves? And then you name the other team. We like them too. Now, you don't need to keep writing the word consecutive if you would like to just do the little ditto marks. Consecutive odd integers. So I'm just giving you examples here so that you understand what this term means. If I start with 1, what comes next? Jim? 3, 5, 7, and so on. Right? So consecutive means the next one in the row, if we were going in order, and if it's consecutive integers, right, then we're doing all numbers. Consecutive odd or even, just the evens or the odds, but still in a row. Now, what if I don't know what the start is? If I start, let's say, let me find a sample here, sample problem. If I say the sum of 2 consecutive integers. So for this you need to read carefully. Is it consecutive integers or is it consecutive even or odd? So just look carefully for the wording. The sum of 2 consecutive integers is 93. And then, so we're first going to write an equation and then we're going to see if we can solve it and figure out what those numbers are. You must write the equation though. Now, let's start. If I have a sum, that means, and it's of 2 things, that's 2 things being added, is 93, right? So first going back to sort of our translating, sum means addition. I've got 2 things I'm adding, is equals 93 for my total. Now, let's look at the sample up here. Let's say I don't know what the first one is. For regular consecutive integers, I can only still use one variable. I can't say x plus y. There's no way to solve that. So what would, if I need to use the x again, what would the next plain integer be? How could I represent that, Diego? Well, that's the same number. I'm saying 2 consecutive integers, so 2 different numbers that come right one after the other. Brian? Good. Notice what Brian did. If the first integer, let's say it was a 1, and it wouldn't be for this problem, but the next one is the original one plus 1 more. Here's your equation. What if it was the same thing? So it's the same thing, but it's 3 consecutive integers. So let's say the rest of it's the same. But instead of 2, it's 3. Well, it would start the same way. Whatever the first number is, the next one's going to be 1 bigger than the original. What's the next one going to be? And again, if you're not sure, look back at my sample numbers. We always start with the original one. The next one would be increased from the original, Vincent, plus 2. Now, you don't need the parentheses. You can leave them out or you can use them. The parentheses for me are just showing here's the first number, the second number, and the third number. If it's consecutive integers, not even or odd, but all integers, each time we start with the original plus 1, plus 2, the next one plus 3, the next one plus 4. Now, if I asked you to solve this first one, let's go back up to the green one. If I asked you to solve this, what would you do? X plus 1 equals 93. What would the next step be? How do we solve it? This is not new. I expect you guys to know this. What would you do? Jim, what's the first thing? Okay, combine like terms. 1x plus 1x makes 2x. So for some of these, I'm going to also ask you to solve because you guys do know how to do this. Okay, the book says write the equation. I'm going to add on to that for some of them, not all of them, that you need to solve it. So Jim was correct. First we combine the like terms. X plus x makes 2x. What's my next step? Pammy? Good. I leave the variable alone. I undo the other stuff. I undo plus 1 by subtracting 1 from both sides. Final step, I divide by 2. Since that's multiplying, I do the opposite. I divide by 2. 46. I get x equals 46. If x equals 46, what would the next number be? If x equals 46, the next number, Carissa?
47.
47. How do we test if we got it right? Well, first you look and you go, are those consecutive? Yeah, 46 and 47, and then you add them together. 46 plus 47, oh, it equals 93. Those are the correct numbers. If you were going to do this one, you do the same thing. X plus x plus x. We're not going to solve this one all the way, but we get 3x plus 3 equals 93. Now, we're not going to solve that one because I just made that one up and I don't think that's going to end up being, oh, it might be whole numbers actually. 30, 31, and 32. But I wasn't sure if that would work out. So we're not going to solve that, but you would solve it the same way. Now, that's for consecutive integers, all numbers. What if now I say, let me find one here. Sorry, I lost my problem. The sum of 3 consecutive even integers. So again, reading carefully to notice that it says even equals, is the sum of 3 consecutive even integers is 66. Now I don't know if that one's going to work. We're not going to solve it because I'm just making up numbers here, so I don't want to end up with decimals. You will get whole numbers for these. But the first thing we need to do is to set up our problem. Sum of 3, okay, that's 3 things being added, is 66 equals 66. I'm going to suggest that you start by doing these little lines for each one, because if you forget a variable, you get the answer wrong. And if you're setting it up for 1, 2, 3 integers, there's more of a chance you'll get it right. Now again, I don't know the first one. I'm always going to call the first one x, or if you want to use a different letter, that's fine. But we always use the same variable throughout the equation. Now, even integers. Let's look back up here at my sample numbers. If the first one is x, the next one is the original number increased by how much? Good, I see lots of fingers. It'd be the original number increased by 2. Because with even integers, we're skipping, right? 2, 4, 6, 8, we're skipping a number, so it increases by 2. What about the third one? Oops, not on the screen. The third one, again, we start with the original increased by, Daniel?
6.
Nope. From 2 to 6, I did not increase by 6, I increased by No. From 2, the original number, now these are not the real numbers, but if this were my original number, first I went up plus 2. Now from here to here, I went up plus, Daniel, plus 4, thank you. The important thing for this, guys, is that it's always going to follow this pattern no matter what the numbers are. If it's consecutive even, each one goes up by 2 from the previous number. So plus 2, well, another 2, add the 2 onto this 2, you get 4. Now, here's the thing where a lot of people mess up. Let's do the exact same problem, but we're going to make it odd. The sum of, of 3 consecutive odd integers is 66. So I'm keeping everything the same so we can just focus on the part that says these are odd integers, consecutive odd integers. The sum of 3 consecutive odd integers is 66. Now, of course, as you do it, you're going to have different answers at the end. They're not all going to be 66. Okay. Again, I'm going to start with x. Look at my sample numbers that I gave you at the start. I'm going to just show it briefly here. We did 1, 3, 5, 7. If they're odd integers, the first one, whatever the variable is, we're going to call it x here. The next one increases. It's the original plus how much? Pammy?
1.
Are you sure about that? For 1 to 3, we only increased by 1? Look at the, no. I feel like you're just naming all the numbers. Look at it. From the original number, how much did it increase by? Pammy, say it with confidence.
2.
2. From this one, guys, this is the mistake everybody makes. They think because it's odd, it increases by an odd amount. It doesn't. It increases by 2. Or from the original to the second one, by 4. It's the same as the even. It's exactly the same because it skips 1. Whether it's odd or even, it still skips 1. So it's going to go up by 2, by 4. If you don't believe me, look at the sample numbers we started with. From the original, plus 2. From the original, plus 4. What would the next one be? From the original, plus 6. I heard it out there. Notice the pattern. Odd or even, it goes up by 2, 4, 6, 8, 10, 12, as many as you have. Each time it jumps by 2 because you're skipping a number. If it's regular consecutive integers, it increases each time by 1. If you forget, pick some sample numbers like I did here. Chances are you're not going to have these small, simple numbers, but look at them or try it with these and see how much does it jump each time. By 1, by 2, by 2. Question? No, stretch it. Now, what about if it said the product? Same stuff, but let's say it says now instead of the sum, this is the last one I want to show you. What if it says, excuse me, the product of, 2 I'm having trouble spelling. Consecutive, let's say, odd integers again. Oh my gosh, I can't spell. Integers is 120. Now, instead of sum, and sorry about the messy writing, consecutive odd integers, product means what? We're going to do what? We're not adding anymore, Diego? Multiplying. I'm going to suggest you just use parentheses. The product of 2 consecutive odd integers. I'm going to multiply them. If you want to put parentheses around both, you can. If I call the first one x, what's the next one? Consecutive odd. Luke.
X plus 3.
Good. X plus 2. Diego? If there was a third one, then it would be x plus 4, but I've just got 2, so we're done. Now, here's what I'm going to ask you to do for these. Guys, when it says sum, please listen. For the problems I give you, when it says sum, you're going to need to solve them and get the answers. What are those integers? For this one, let me show you how far you need to go with this. If I distribute this x, let's see what we get. X times x, what do I get? Jim? No. Vincent. X times x. Not 2x. X squared. Guys, real quickly, the difference. Shh. Over here, this is going to be a big thing this year. When you add x plus x, you get 2x. X times itself. When you're multiplying it by itself, it is the exponent 2. This makes a difference. These are different answers. If x was 5, 5 plus 5, or 2 times 5, that's 10. 5 times 5, that's 25. They are different answers. So that's why we're doing this one. That's okay. X times x, x squared. X times 2. Jim, there's the 2x. All right, I'll be making a seating chart later for you guys. When it's product and you end up with an exponent like this, this is as far as you need to go. Either one of these actually would be fine. Because guess what? You don't know how to solve this yet. This is a quadratic equation. We're not getting to solving this until, we'll start a little bit in chapter 5, but really not until I think it's chapter 12, the end of the book. You don't know how to solve this yet. So, for the ones that are product, where you get an exponent, you stop with the equation. You can stop right there. You don't have to solve it, because you don't know how yet. There's a lot of different ways to solve it. Chapter 12, you're going to learn 4 different methods to try to solve it. But we're clearly not on chapter 12 yet. So, for homework, or I should say classwork, you're going to try, let's see, numbers 1 through 10 all. The ones you need to solve, I'll put the numbers here, but again, any of the ones that are sum or addition, I'm going to ask you to solve and get the answers. So that's going to be numbers, let's see, 1 through 6, and number 9. You can skip solving number 10 and number 7 and 8. Write the equation and solve for some of them.